In this session, we'll be reviewing the power and benefits of implementing a secure software supply chain and how we can gain a cloud-like experience with the flexibility, speed, and security of modern software delivery. Hi, I'm Matt Bentley, and I run our technical pre-sales team here at Mirantis. I spent the last 6 years working with customers on their containerization journey. One thing almost every one of my customers is focused on is how they can leverage the speed and agility benefits of containerizing their applications while continuing to apply the same security controls. One of the most important things to remember is that we are all doing this for one reason, and that is for our applications. So now let's take a look at how we can provide flexibility at all layers of the stack from the infrastructure on up to the application layer. When building a secure supply chain for container-focused platforms, I generally see two different mindsets in terms of where the responsibilities lie between the developers of the applications and the operations teams who run the middleware platforms. Most organizations are looking to build a secure yet robust service that fits their organization's goals around how modern applications are built and delivered. First, let's take a look at the developer or application team approach. This approach follows more of the DevOps philosophy, where developer and application teams are the owners of their applications from the development through their life cycle all the way to production. I would refer to this more of a self-service model of application delivery and promotion when deployed to a container platform. This is fairly common in organizations where full stack responsibilities have been delegated to the application teams. Even in organizations where full stack ownership doesn't exist, I see the self-service application deployment model work very well in lab development or non-production environments. This allows teams to experiment with newer technologies, which is one of the most effective benefits of utilizing containers. In other organizations, there is a strong separation between responsibilities for developers and IT operations. This is often due to the complex nature of controlled processes related to the compliance and regulatory needs. Developers are responsible for their application development. This can either include Docker at the development layer or be more traditional throw-it-over-the-wall approach to application development. There's also quite a common experience around building a center of excellence with this approach, where we can take container platforms and be delivered as a service to other consumers inside of the IT organization. This is fairly prescriptive in the manner of which application teams would consume it. When examining the two approaches, there are pros and cons to each. Process, controls, and compliance are often seen as inhibitors to speed. Self-service creation, starting with the infrastructure layer, leads to inconsistency, security, and control concerns, which leads to compliance issues. While self-service is great, without visibility into the utilization and optimization of those environments, it continues the cycles of inefficient resource utilization. And a true infrastructure as a code experience requires DevOps-related coding skills that teams often have in pockets, but maybe aren't ingrained in the company culture. Luckily for us, there's a middle ground for all of this. Docker Enterprise Container Cloud provides a foundation for the cloud-like experience on any infrastructure without all of the out-of-the-box security and controls that our professional services team and your operations team spend their time designing and implementing. This removes much of the additional work and worry around ensuring that your clusters and experiences are consistent while maintaining the ideal self-service model, no matter if it is a full stack ownership or easing the needs of IT operations. We're also bringing the most natural Kubernetes experience today with Lens to allow for multi-cluster visibility that is both developer and operator friendly. Lens provides immediate feedback for the health of your applications, observability for your clusters, fast context switching between environments, and allowing you to choose the best in tool for the task at hand, whether it is the graphical user interface or command line interface driven. Combining the cloud-like experience with the efficiencies of a secure supply chain that meet your needs brings you the best of both worlds. You get DevOps speed with all the security and controls to meet the regulations your business lives by. We're talking about more frequent deployments, faster time to recover from application issues, and better code quality. As you can see from our clusters we have worked with, we're able to tie these processes back to real cost savings, real efficiency, and faster adoption. This all adds up to delivering business value to end users and the overall perceived value. Now let's look at see how we're able to actually build a secure supply chain to help deliver these sorts of initiatives. In our example secure supply chain, we're utilizing Docker Desktop to help with consistency of the developer experience, GitHub for our source control, Jenkins for our CI/CD tooling, the Docker Trusted Registry for our secure container registry, and the universal control plane to provide us with our secured container runtime with Kubernetes and Swarm, providing a consistent experience no matter where our clusters are deployed. We work with our teams of developers and operators to design a system that provides a fast, consistent, and secure experience for my developers that works for any application, brownfield or greenfield, monolith or microservice. Onboarding teams can be simplified with integrations into enterprise authentication services, calls to GitHub repositories, Jenkins access and jobs, universal control plane and Docker Trusted Registry teams and organizations, Kubernetes namespace with access control, creating Docker Trusted Registry namespaces with access control, image scanning, and promotion policies. So now let's take a look and see what it looks like from the CI/CD process, including Jenkins. So let's start with Docker Desktop. From the Docker Desktop standpoint, we'll actually be utilizing Visual Studio Code and Docker Desktop to provide a consistent developer experience. So no matter if we have one developer or 100, we're going to be able to walk through the consistent process through Docker container utilization at the development layer. Once we've made our changes to our code, we'll be able to check those into our source code repository. In this case, we'll be using GitHub. And then when Jenkins picks up, it will check out that code from our source code repository, build our Docker containers, test the application, it will build the image, and then it will take the image and push it to our Docker Trusted Registry. From there, we can scan the image and then make sure it doesn't have any vulnerabilities. Then we can sign them. So once we've signed our images, we've deployed our application to dev, we can actually test our application deployed in our real environment. Jenkins will then test the deployed application, and if all tests show that it is good, we'll promote our Docker image to production. So now let's look at the process beginning from the developer interaction. First of all, let's take a look at our application as it's deployed today. Here we can see that we have a change that we want to make on our application. So our marketing team says we need to change containerized Nginx to something more Mirantis branded. So let's take a look at Visual Studio Code, which we'll be using for our IDE to change our application. So here's our application. We have our code loaded, and we're going to be able to use Docker Desktop on our local environment with our Docker Desktop plugin for Visual Studio Code to be able to build our application inside of Docker without needing to run any command line specific tools. Here with our code, we'll be able to interact with Docker, make our changes, see it live, and be able to quickly see if our changes actually made the impact that we're expecting in our application. So let's find our updated tiles for our application, and let's go ahead and change that to our Mirantisized Nginx instead of containerized Nginx. So we'll change it in the title and on the front page of the application. So now that we've saved that change to our application, we can actually take a look at our code here in VS Code, and as simple as this, we can right-click on the Docker file and build our application. We give it a name for our Docker image, and VS Code will take care of the automatic building of our application. So now we have a Docker image that has everything we need in our application inside of that image. So here we can actually just right-click on that image tag that we just created and do run. This will interactively run the container for us. And then once our container is running, we can just right click and open it up in a browser. So here we can see the change to our application as it exists live. So once we can actually verify that our application is working as expected, we can stop our container. And then from here, we can actually make that change live by pushing it to our source code repository. So here we're going to go ahead and make a commit message to say that we updated to our Mirantis branding. We will commit that change, and then we'll push it to our source code repository. Again, in this case, we're using GitHub to be able to use as our source code repository. So here in VS Code, we'll have that pushed here to our source code repository, and then we'll move on to our next environment, which is Jenkins. Jenkins is going to be picking up those changes for our application, and it checked it out from our source code repository. So GitHub notifies Jenkins that there's a change, checks out the code, builds our Docker image using the Docker file. So we're getting a consistent experience between the local development environment on our desktop, and then in Jenkins, where we're actually building our application, doing our tests, pushing it to our Docker Trusted Registry, scanning it, and signing our image in our Docker Trusted Registry, and then deploying to our development environment. So let's actually take a look at that development environment as it's been deployed. So here we can see that our title has been updated on our application, so you can verify that it looks good in development. If we jump back here to Jenkins, we'll see that Jenkins go ahead and runs our integration tests for our development environment. Everything worked as expected, so it promoted that image to our production repository in our Docker Trusted Registry, where then we're going to also sign that image. So we're signing that, yes, we've signed off that has made it through our integration tests and it's deployed to production. So here in Jenkins, we can take a look at our deployed production environment where our application is live in production. We've made a change, automated in a very secure manner. So now let's take a look at our Docker Trusted Registry, where we can see our namespace for our application in our simple Nginx repository. From here, we'll be able to see information about our application image that we've pushed into the registry, such as the image signature, when it was pushed by who, and then we'll also be able to see the scan results of our image. In this case, we can actually see that there are vulnerabilities for our image, and we'll actually take a look at that. Docker Trusted Registry does binary level scanning, so we get detailed information about our individual image layers. From here, these image layers give us details about where the vulnerabilities were located and what those vulnerabilities actually are. So if we click on the vulnerability, we can see specific information about that vulnerability to give us details around the severity and more information about what exactly is vulnerable inside of our container. One of the challenges that you often face around vulnerabilities is how exactly we would remediate that in a secure supply chain. So let's take a look at that. In the example that we were looking at, the vulnerability is actually in the base layer of our image. In order to pull in a new base layer for our image, we need to actually find the source of that and update it. One of the ways that we can help secure that as a part of the supply chain is to actually take a look at where we get our base layers of our images. Docker Hub really provides a great source of content to start from, but opening up Docker Hub within your organization opens up all sorts of security concerns around the origins of that content. Not all images are made equal when it comes to the security of those images. The official images from Docker Hub are curated by Docker, open source projects, and other vendors. One of the most important use cases is around how you get base images into your environment. It is much easier to consume the base operating system layer images than building your own and also trying to maintain them. Instead of just blindly trusting the content from Docker Hub, we can take a set of content that we find useful, such as those base image layers or content from vendors, and pull that into our own Docker Trusted Registry using our mirroring feature. Once the images have been mirrored into a staging area of our Docker Trusted Registry, we can then scan them to ensure that the images meet our security requirements, and then, based off the scan result, promote the image to a public repository where we can actually sign the images and make them available to our internal consumers to meet their needs. This allows us to provide a set of curated content that we know is secure and controlled within our environment. So from here, we can find our updated Docker image in our Docker Trusted Registry, where we can see that the vulnerabilities have been resolved. From a developer's point of view, that's about as smooth as the process gets. Now let's take a look at how we can provide that secure content for our developers in our own Docker Trusted Registry. So in this case, we're taking a look at our Alpine image that we've mirrored into our Docker Trusted Registry. Here we're looking at the staging area where the images get temporarily pulled because we have to pull them in order to actually be able to scan them. So here we've set up mirroring, and we can quickly turn it on by making it active. And then we can see that our image mirroring will pull our content from Docker Hub and then make it available in our Docker Trusted Registry in an automatic fashion. So from here, we can actually take a look at the promotions to be able to see how exactly we promote our images. In this case, we created a promotion policy within Docker Trusted Registry that makes it so that content gets promoted to a public repository for internal users to consume based off of the vulnerabilities that are found or not found inside of the Docker image. So our actual users, how they would consume this content is by taking a look at the public to them official images that we've made available. Here, again, looking at our Alpine image, we can take a look at the tags that exist. We can see that we have our content that has been made available. So we've pulled in all sorts of content from Docker Hub. In this case, we've even pulled in the multi-architecture images, which we can scan due to the binary level nature of our scanning solution. Now, let's take a look at Lens. Lens provides capabilities to be able to give developers a quick, opinionated view that focuses around how they would want to view, manage, and inspect applications deployed to a Kubernetes cluster. Lens integrates natively out of the box with Universal Control Plane client bundles, so your automatically generated TLS certificates from UCP just work. Inside our organization, we want to give our developers the ability to see their applications in a very easy to view manner. So in this case, let's actually filter down to the application that we just deployed to our development environment. Here we can see the pod for our application, and when we click on that, we get instant detailed feedback about the components and information that this pod is utilizing. We can also see here in Lens that it gives us the ability to quickly switch context between different clusters that we have access to. With that, we also have capabilities to be able to quickly deploy other types of components. One of those is Helm charts. Helm charts are a great way to package up applications, especially those that may be more complex, to make it much simpler to be able to consume and version our applications. In this case, let's take a look at the application that we just built and deployed. In this case, our simple Nginx application has been bundled up as a Helm chart and is made available through Lens. Here we can just click on that description of our application to be able to see more information about that Helm chart. So we can publish whatever information may be relevant about our application, and through one click, we can install our Helm chart. Here it'll show us the actual details of the Helm chart, so before we install it, we can actually look at those individual components. So in this case, we can see that it's created an ingress rule, and then it will tell Kubernetes how to create the specific components of our application. We just have to pick a namespace to deploy it to. And in this case, we're actually going to do a quick test here, because in this case, we're trying to deploy the application from Docker Hub. In our Universal Control Plane, we've turned on Docker Content Trust Policy Enforcement, so this is actually going to fail to deploy. Because we're trying to deploy our application from Docker Hub, the image hasn't been properly signed in our environment. So the Docker Content Trust Policy Enforcement prevents us from deploying our Docker image from Docker Hub. In this case, we have to go through our approved process through our secure supply chain to be able to ensure that we know where our image came from and that it meets our quality standards. So if we comment out the Docker Hub repository and comment in our Docker Trusted Registry repository and click install, it will then install the Helm chart with our Docker image being pulled from our DTR, which then has a proper signature. We can see that our application has been successfully deployed through our Helm chart releases view. From here, we can see that simple Nginx application, and in this case, we'll get details around the actual deployed Helm chart. The nice thing is that Lens provides us this capability here with Helm to be able to see all of the components that make up our application. From this view, it's giving us that single pane of glass into that specific application so that we know all of the components that is created inside of Kubernetes. There are specific details that can help us access the application, such as that ingress rule that we just talked about gives us the details of that, but it also gives us the resources such as the service, the deployment, and ingress that has been created within Kubernetes to be able to actually have the application exist. So to recap, we've covered how we can offer all the benefits of a cloud-like experience and offer flexibility around DevOps and operations controlled processes through the use of a secure supply chain, allowing our developers to spend more time developing and our operators more time designing systems that meet our security and compliance concerns.